Here we have the volume of the sphere, and the formula to get the volume of the sphere is 4/3 times pi times the radius to the third. And so this equation shows how the volume and the radius, how they related. So they related by this equation. And so what we like to do is come up with an equation that shows how the rates of the volume and the rate of change of the volume and the rate of change of the radius, how they related. And so here we have the sphere with radius 3, and so the corresponding volume is about 113. And so if we increase the radius, then we're also increasing the volume of the sphere. And so if the radius, the rate of change of the radius is fast, then the rate of change of the volume is also fast. But we like to know how the two rates related. And then we like to know at the instant when the radius is 4 inches, what is the rate of change of the volume at that instant. So that's when it's 4 inches. And so let dV dt be the rate of change of the volume with respect to time, and then dr dt be the rate of change of the radius with respect to time. And then what we're going to do is we need to do, we need to do implicit differentiation. So v equal to 4/3 times pi times r to the third. V be the same as 1v. And here we do an implicit the differentiation with respect to time. So here the variable is v, and we're doing derivative with respect to time. So we'll use the chain rule. We'll do the regular derivative. Derivative 1v, just 1. And then since the variable here is v, and we're doing derivative with respect to time, then we need to multiply by d. We need to do it multiply by the derivative of v with respect to time. And then 4/3 pi is the constant. And then times the derivative of r to the third is 3r to the second. And since the variable here is r, or radius, and we're doing derivative with respect to t, then we have to multiply by dr dt. And then simplify, we get 1 dv dt is just dv dt, and then 4/3 times 3 is 4. So 4/3 times 3 is 4. And then we get pi r squared. And so this equation right here, how dv dt, which is the volume, the rate of change of the volume with respect to time, and the rate of change of the radius with respect to time, are related. And now we like to know at the instant so at the instant when the radius is 4 inches, and then we have to be given the rate of change of the radius. And so suppose we given that the rate of change of the radius, meaning the radius is changing at a rate of 3 inches per minute. And then at the instant when the radius is 4, what is the rate of change of the volume? So that's what we like to know. So looking at the graph, and so here we're given that the radius is changing at a rate of 3 inches per minute. And so the volume also changes, and then at the instant, that's when the radius is 4 inches. We like to know at this instant, what is the rate of change of the volume? How fast is the volume changing at this instant? So that's what we're looking for. And so to get dV dt, we just use this equation right here. And so we get 4, and then pi. And then we want to know at the instant when the radius is 4. And then we're given that the rate of change of the radius with respect to time is 3. And if we multiply this out, this comes out to be about 603.19. And this is the unit. And so the rate of change of the volume with respect to time would be about 603.19 cubic inches per minute. And so at the instant when the radius is 4 inches, the volume, the rate of change of the volume at that instant is 603.19 cubic inches per minute.